For today's lesson, we're going to look at how we can apply the knowledge that we already have now about Pythagoras to a wide range of contexts or scenarios that you could come across in real life. So the first one here is using the context of perimeter. So we're going to use Pythagoras and then find the perimeter of this triangle. So first of all, what we're going to do is label the sides. So we're going to label the side opposite our right angle as C, and then the other two sides A and B. Then first step, always copy down the formula, substitute in what you know and what you're trying to find out. So instead of C squared, I'm going to write Z squared, just because that's the letter that we're given in the question. For A and B, we've got 5 squared plus 12 squared. We could actually do this one without a calculator, because 5 squared is 25 and 12 squared is 144. So when you add them together, you get that Z squared is 169, and we have to find the square root of that to find Z, which is what we're trying to find, so that we can then find the perimeter of the triangle. So Z is the square root of 169, which you could figure out without a calculator because it's a nice whole number, is 13 metres. Okay, don't worry if you do still have to use a calculator for that, that's okay. And then we've found this length Z centimetres, but what we haven't done is answered the question, which is asking us to find the perimeter. So perimeter, we know from our last topic, is the distance around the outside of a shape. So we're going to start here and add the 5, this side here, which we know is 13, and then this bottom, which is 12. So 5 plus 13 plus 12 gives us an answer of 30 metres, and that's the perimeter of the triangle. For the second example, we're asked to find the missing length x, but what we'll notice about this question, which is different to the ones that you've seen before, is that this isn't a right angle triangle, it's an isosceles triangle, and that is denoted by the two blue lines on either side of the triangle. What that tells us is that the triangle can be split down the middle, essentially, in that we could form two equal right angle triangles. So I'm going to draw just a quick sketch of the right angle triangle that I'm going to actually be working on just now. And I would really encourage you to do that. So when you're doing a question where it doesn't actually give you a right angle triangle, but you have to either split the shape or do something else with the shape to form one, then draw a version of that triangle separately to your sketch of the question. And we're being asked to find this side here, the sloping side, x millimetres. We know that this height here is 16, because that goes from the top of the triangle down to the bottom, even when it's split in half. So that's 16 millimetres. And then we have to think about the bottom part. So we know that from here all the way along here is 12 millimetres, but if we're splitting that triangle down the middle, then the bottom part is 8 millimetres. So there we have a right angle triangle. We know two sides and we can use Pythagoras to find the third side. So just doing Pythagoras as normal, label the sides. So this is C and the other two sides are A and B, and then we'll copy down the formula. So C squared equals A squared plus B squared, and then we need to fill in what we know and what we're trying to find out. So instead of C squared, I'm going to write X squared, and then A squared is 16 squared plus 8 squared. And you're just typing that all into your calculator in the one go. So you should be really comfortable by now onto the second exercise in this topic with squaring things and taking the square root of things in your calculator. That gives us that x squared is 320, but we don't really care about x squared, all we care about is x. So to find x, and again, just note that we've gone from talking about things in terms of x squared to just x on our left-hand side. X is the square root of 320, which if you do in your calculator, remembering to press the little S and then arrow D button to turn it into a decimal, gives you 17.8885 ... blah blah blah. And I'm just going to round that to 17.9 millimeters. And I always think that it's quite nice just to specify that you're rounding it to one decimal place. Because the question doesn't specify what to round to, you can round to whatever you want as long as it's sensible and as long as it's rounded appropriately. So 1 or 2 decimal places are your best bets. This question is asking us to find the length r kilometers, which is the sloping length here, in this shape. So this shape is a compound shape. Remember we did this when we spoke about area and perimeter. So it's a compound shape and it's made up of a right angle triangle at the top. So I'll mark the little right angle on there, and a rectangle at the bottom. So again, it's one of those questions where the right angle triangle doesn't instantly present itself to you. You have to do a little bit of digging, a little bit of playing around to find the right angle triangle. So I'm going to go to the side and draw that triangle, just a sketch, so it doesn't need to be perfectly measured out or done to scale. Just so that I've got the shape that I'm working on away from kind of all the sort of clutter that's going on in this big shape here. So we're going to fill in the sides that we know and then mark on the sides that we want to find. So I want to find this side here, which is r kilometers. And if I'm going to be able to do Pythagoras on this, it means I need to already know this side here and this side here. So the bottom side goes from this part over to here. And that's the same as the length at the bottom of the rectangle, which means that this side here at the bottom has to be 12 kilometers because they're the same length. Then we have to look at this vertical side. And if we know that from the bottom all the way up to the top is 26 kilometers, and we know that from the bottom up to where the triangle starts is 19 kilometers, we can do a quick taking away sum there. So just doing 26 take away 19 to work out what this height is. And it's 7 kilometers. So now we have a right angle triangle and we can go ahead and work out Pythagoras on that. So we're going to label the sides, copy down the formula, and then sub in what we know. So this side here, R, is going to be our hypotenuse, so our C, and then A and B. So if we copy down the formula, again, you should be really familiar with this formula by now. You'll have done loads of practice and seen about 6 examples now of it being worked out for you. We're going to replace the C squared with R squared, and then substitute in your values for A and for B. So in the calculator, you don't have to do a step where you say r squared equals 49 plus 144. You can if you really, really want to, but I just think it gives you an extra step and an extra opportunity to make a mistake. And I would say don't bother because there's no marks available for it. So just go straight from that line there to r squared equals 193. And if r squared equals 193, then r equals the square root of 193, which is 13.8924 So just write maybe 4 or 5 decimal places and just show the dots just to make it clear that you know that this number is going to go on forever and ever until you round it. And we're going to round it just again to 1 decimal place, so to 13.9 kilometers. Just going to make clear that I'm rounding that to 1 decimal place. And that is the sloping length, r kilometers. That should now be all of the different types of examples covered that you're going to come up against in this exercise. If you're having any issues with it, then please let me know.